which means I do very little talking, we do a lot of talking. And I see some people who don't speak Chinese, some people who do, some people with earpieces, some don't. I can try to repeat stuff in both Chinese and English, so if that's easy for everybody. 就这因为是一个 bird of feather 的 session， 所以其实是大家的 participation 很重要。那个我看到有几个不会讲中文的，大多数是会讲中文的，我尽量两个可以都说。然后你问问题也尽量两个可以都问，然后就是我们看怎么能够让大家最大程度的都能 participate， 然后这个 have a discussion together。Okay， 然后我的计划就是I'm going to spend 20% time just setting up the context。我会讲一下我们为什么这是一个什么样的 problem space， 我们为什么要解决这个 problem space。And then 80% of it is going to be discussion. RFS, and then I think it's a problem that's going to go beyond the session today. So we're going to have to figure out how we follow up and work together to solve the problem of access control in a hybrid cloud deployment space. Okay, so all right. The first thing I want to paint a picture for any of you who work with cloud, especially work with multi-cloud and Kubernetes and Istio. When you think about what life looks like for a user or an admin when it comes to dealing with access policies, this is what they deal with today. So it's a pretty big mess. On the infrastructure layer, they can use one or more clouds. So whether it's AWS, or GCP, Ali Cloud, or your on-prem infrastructure, which will come with its own access policies, such as IAM, networking firewall rules, right, and quota, any other policies you might have. The layer above, that's where you can run Kubernetes, which comes with its own policies, such as RBAC, ABAC, right? Also Kubernetes quota and the Calico networking policy, and so on. And above that, you have Istio, where you can define, again, different kinds of access policies, including Istio's RBAC policies, Istio's own security policies. And on top of that, you run your applications, where if you have data access, sometimes you use OPA, sometimes you have your own IAM. And at the end of the day, all of these application layers then lead to your data. So you can take a key off a service account to then get access to your data, which can also be accessed via IAM. So if you try to answer the question of which users can access my data, or why can a user not access my data, it's really complicated. You're looking through these dozens of different access policies to try to figure out what you need to change, or when you're making a change, what is the total effective policy? What is the consequence of the change you're making? So, and then what we notice is that a lot of users and admins look at this, they're a little paralyzed. They go, I'm not really quite sure what's the best practice around all of these policies, how do I troubleshoot them, how do I understand them, how to use them in combination with each other. So since we've got more than a dozen of policies there, and in fact, when I listed those, as soon as I showed it to one of our engineers, he said, no, it's not a complete picture. You also need to think about authentication, binary authorization, quota, audit policies. There's no end to the list, right? So when we look across these more than a dozen of different policies, we can see many opportunities for inconsistencies. So first of all, syntaxes. Right, some of RBAC has its syntax, OPA has its syntax. Any new policy people invent can have their own syntax. And not only that, when you are trying to deploy the policies automatically, you can be using one or more of the configuration management languages. So you could be using Terraform, Chef, on GCP you have Deployment Manager, on Amazon you have CloudFormation, you use Salt, Ansible, and so on. So the syntax gets very complicated. We have to learn how to express the same thing in many different ways. And then best practices, right? Most of the cloud customers come to us and say, hey, don't give me a set of 20 different features or 20 different policies. Tell me how to use them. Give me the opinionated best practice. Give me a solution. Give me a template that I can start from. When you have these 20 policies, every policy maker has their own best practice. They come up with their own recommended defaults. But when you put them together, do they actually make sense? There's nobody doing end-to-end testing. There's nobody thinking through the effect of the best practices when they work in conjunction with each other. Let's pick some other examples. Error message is another really tricky place, right? There's no common standard for producing error message for access denied, right? It doesn't tell you, sometimes it just says access denied. It doesn't tell you it's because of RBAC, it's because of Istio layer, it's because of networking policy, and then it's up to the admin to figure out on their own exactly which policy even to start with. Other things like explainability and simulation start to become more and more important. The more layers you have, the more sophisticated the system gets. Any admin or any user wants to figure out when I'm making a change, what is the end result, right? How is it going to impact my production traffic? And when something goes wrong, how do I go about fixing it? What are different options I have? And again, if every one of these policies work in isolation in their own silo, then we don't have an end-to-end story to help anybody to really manage access control for the hybrid cloud. See, do we want to pick anything else? Also, labels and groups. Some policies go with a hierarchical structure, right? They group resources together. There's a kind of ownership structure, typically in AD and in LDAP. Policies inherited down a strict hierarchy. In Kubernetes, you've got namespaces, which are very flat, and then we can put labels on them. We use label selector. That's a very kind of ABAC and flat type of policy. Again, when you put a hierarchical policy and a flat policy together, how do you understand the total effect in the end? How do you even go about designing how you manage and group your different resources so you can effectively apply policies to them? So now all of these things are really tricky problems, but at the end of the day, why do we even care? Is it okay if it's just messy? So we look at reality, what happens when it is messy. Even those of us who work on cloud, we're already confused by this. And you can imagine how hard it is for our customers. So as an enterprise admin or developer tries to make sense of these things, first they see a lot of inconsistencies. They need to do this, need to learn 20 different ways of doing the same thing. And that tends to lead to, it's a really complex system. Nobody fully understands it. When it's complex, what we notice is that two types of things happen. Either people do nothing. It's inertia. They just decide it's too hard. I'm not going to make any change. Right? Or they do make change, but because they don't understand it, they misconfigure the system. What typically happens is when a developer goes to an admin and says, hey, I need access to the storage bucket. And the admin says, OK, I've made a policy change that I think I need to make for you. Can you try it? They go back and says it doesn't work. And 3 times later, when it still doesn't work, the admin, out of goodness of their heart, want to unblock a developer. We usually just say, OK, I'm going to make the bucket public. That's how we end up seeing so many security incidents due to sensitive data stored in public buckets. So I did a quick search, and then they all lead to really kind of loss of control and breach of sensitive data. So when I did a quick search on the internet looking for articles related to kind of inconsistent configurations and security breaches, there's no shortage of these stories, right? A lot of cloud users already feeling like it's too complex. We need a unified stack. We just can't manage so many inconsistent and complex configurations and policies. And then when we do configure them wrong, there's no shortage of data breaches. It's no longer, we're almost getting to the point of being numb. Every month, there's yet another headline about data breaches. So my ask is we collectively need to figure out what are we going to do about it, because at the end of the day, when we get to such a complex and insecure system, we all suffer. It's not about a single company or single cloud, right? Cloud in general gets a bad reputation. You probably already have either people in your own company or your customers saying to you, I'm not really sure if I want to move to the cloud. I don't know how secure it is, or I don't know how it impacts compliance auditing. Right, and then I think we collectively, Kubernetes provides a great, CNCF provides a great framework for us to kind of work in collaboration with each other to see if there's a way to come up with some standards, some good way of making sure these policies work with each other, that we can provide a consistent experience to customers, not for single cloud, but really across multiple clouds and across multiple stacks. So from there on, we go to discussions. Any ideas, anything you've been thinking about working on that will help us to solve this problem here? 大家也可以用中文提问。So I'm going to point Tim. Yes.
I think another Another dimension that I've found really challenging is sort of the config validation type policy versus the more like runtime enforcement policies. So as an example, something like admission control in Kubernetes versus network policy, which is applied to a running container. And I've found it challenging to kind of reconcile those models and think about how they could compose well.
Anybody else have encountered config validation? 就大家有没有，比如说你有一些 policy 是说这个不是说谁能不能干什么事情，而是说我只能用这些 container 或者我的 network 不能有 external IP， 类似于这样的 policy， 大家有没有 experience？ So to extend what Tim was talking about, what we find is there are policies that are very much about whether you are able, whether you are able to access particular resource or to call particular API, typical IAM and RBAC type of policies. That's one type of policy. The other type of policy that's become very popular, and I think OPA has been doing some work in that area, is about configuration validation. So yes, you can create a namespace, but only with certain configurations, right? Or yes, you can, you can set up your network configurations, but only within these three choices. So to validate, certain configurations can be technically correct, but for your particular environment, for your security requirements, or for your auditing requirements, they're not desired by the administrators. I don't know, has anybody else encountered these kind of, so we've noticed is in some, it's kind of a spectrum, right? It depends on your culture. In some companies, it's very bottom up. The developers have a lot of freedom. So they're told to just go, create your own namespaces, create your own clusters, create your own services, run whatever you want, and the admins will observe on the side or publish some best practice guidelines, hoping that the developers will adhere to them. In the other extreme, we've also seen environments where it's very top-down. The admins get to control everything. When developers need to go and deploy something, especially when it's in the production environment, what they actually need to do is to create a file ticket. And it goes through a system, the central admin team sees that, and then they're the only people who are able to actually go and create these resources in production. So it's kind of saying it's a spectrum, right? And then more and more popular, the best practice that starts to emerge we're seeing is to kind of put the same CI/CD and DevOps experience. Usually you do that with from code to binary to production. We're seeing the same trend of using that kind of workflow for policy management. So we're actually seeing a number of enterprise customers, because from my point of view, I've seen that more kind of in Europe and in the US, and I'm sure it's starting to happen in Asia as well, where they build a CI/CD pipeline for any policy and config deployment as well. So all the policies sit in a central repo, right? And then from there on, whenever you need to make any change to the policies, nobody can touch production. Only a service account can automatically deploy things to production. So then what you do is to push any changes into the Git repo, and then from there on goes through the same request approval workflow, the CI/CD pipeline to eventually get to production. Now that kind of framework creates a space for doing configuration validation kind of policies, right? So as you can imagine, anybody who's familiar with CI/CD for code and binaries, there are things like pre-submit checks. Right, you can check whether the code is even valid. Static analysis. You can do that at a point when the code gets into repo, or when the code gets from your initial dev branch into production branch. And then when we do that for policies, that also gives us an opening, a place where we can do some similar static analysis on a policy. For example, you can some companies can even talk about things like, we want to name namespaces the same way, right? There's a certain format we name them, and then you can check at a point when the policy change gets into a central repo whether that satisfies your company's policies. So I don't know if anybody else have had experience kind of doing configuration validation or running CI/CD pipelines for their policies. Yes, the gentleman in the back.
Thank you. I mean, you've touched on basically the kind of things we do as well, just to put some more flesh on those things. Certainly the difference between the sort of network policy, which can only really be validated by dynamic test against the cluster. Like statically analyzing those routes is really difficult, versus things like pod security policy, and I guess RBAC also kind of falls into the dynamic test as well, because you can I guess there's a gray area there, but again, we dynamically test those. But in terms of the kind of commit to a Git repository, have a pull request, have that checked over by somebody with centralized access, we then run static analysis on YAML, which just kind of feels weird, but ultimately with this fully declarative system, like where else do you put those sanity checks? So for example, like we actually make sure that if someone wants to make a change to a pull request to the configuration repo for a given namespace, and they change the pod security policy, so the system configuration for that as opposed to the developer configuration, and the division there is the system stuff is what the SRE team control, I mean, in our model for this, versus the developers have access to change things like network policy, for example. But if they want to make a change to the pod security policy, that has to go back in through the system repo, and then the CI actually checks that they haven't turned off host, disabling the host sharing of namespaces and privilege and things like that. So while it feels kind of strange to do, ultimately, in order to kind of just expedite that process and have as much collaboration as possible, we have meta tests even for our sort of static YAML configuration as well.
Cool, yeah. And that's a great point. Like when you're making changes to policies, a lot of time it's not about a single persona, right? You might have multiple admin teams. One manages the actual RBAC policies versus some others that do networking policies. And you also have developers who might be able to control policies to some extent for their own namespaces. So when you have multiple people collaborating, that's also where the Git workflow actually is built for people to collaborate. You can do request approval workflows. You can kind of fork branches and merge back, and we can really kind of leverage the same existing workflows for the policy world as well. So I'm just going to throw out a few ideas of when I look at this long list of policies, trying to think how we can make sense out of them. Yeah, question? Oh yeah, that would be great. Can we? Who has the microphone?
Thank you. So I just want to bring up another idea about here. So I understand the inconsistency between these security policies because they operate at different layer. Some of them, they are for the IP layer. Some of them, they are for the service level, like the Istio RBAC. The Kubernetes network policies for the IP level. The operating system, they have their like write permission or read permission for files level. So I understand this in inconsistency because they have different abstract here. But the question is, does the complexity comes from the inconsistency? Because essentially they are different. So it's just what it is. So it's hard to find a unique model to like represent the different security policies at a different level. So could it be possible that the complexity comes from the people, the operator, the programmer? We do not have a full understanding from the lowest level to the upper level. We are good at like one specific level. Someone who is working on the network policy, they may do not have enough knowledge about the Istio RBAC policy. So could it be possible we can mitigate this by increase the observability of these policies? Like we have a standard about when a request is denied, we have a standard response. For now, I think different levels, they have different behavior. In IP level, when a request is denied, it just drops the packet. And from the user perspective, they only say like timeout. From the Istio level, when a request is denied, probably it only returns a 503 unauthorized code, and the user they say this in the browser. And maybe we can mitigate this by like creating a standard response or something like this.
Yeah, that's a really great point. So one of the, when we saw so many policies, one of our first thought was, is it just because we're not being responsible in creating policy? There are too many. Can we consolidate? Can we actually make them same policy? We came to that realization, right? They're actually different layers. Actually different use cases. I think we will perpetually live in a world of many policies. serving different purposes. So and then that's where I think some of the ideas we start developing are more like there will be many policies, there will be different policies. The things we can make consistent, like you said, right? Standards in things like error reporting, and also in things like workflows, right? If we're ever going to do things like simulation, is there a standard interface for different type of policies to plug in so you can all result in the same simulation experience for the end admin or the end user?
Thank you.
Yeah, so then we can talk about such, that brings us to another thing we can talk about. If we look at those different layers, so we actually thought about, are there ways to make the syntax a little simpler, right? Knowing there are different policies, are there ways to at least bring the syntax to be somewhat simpler, to have a framework to think about how they fit together? And then are there ways to standardize workflows, to standardize, all the other analytics interface as well? On the syntax layer, at a very basic level, I've started thinking about, CRDs and KRM is a great interface, right? So Istio Kubernetes, where everything's converging into, describing your resources as CRDs. And maybe that's another thing that each other cloud, all the different clouds, all the different platforms can also start converging on. Because if we can converge on a similar way to describe resources, then on top of that, the existing policies like RBAC and OPA can potentially work across multiple platforms. And we've thought about RBAC is a great type of policy for kind of more coarse-grained admin operations, right? If you fit into one of the standard verbs, it describes permissions for you pretty well. And then when you get into data access, that tends to get more granular. So people want to do data access not only by RBAC policies, but also by, for example, being context aware. Are you coming from the right IP address? Is it the right time of the day? Or depending on the content of the data. So you can say, you have access to the table, but only if the column name equal to blah, or the value equal to blah, right? So you can filter out the more sensitive data. So we're seeing, the trend we're starting to see is RBAC for the admin operations and kind of OPA or OPA and friends for more data access, more granular policies. I want to see if that resonates with everybody else here. And then we can talk about what happens in the higher layer, in the management layer, right? So the GitOps experience does seem to be, we've seen a lot of customers who natively start to move towards a GitOps experience for managing the many different policies. So you can have different types of policies. You can even have policies for different platforms. However, Git, the source of truth, is where you can actually have a lot of them stored together and centrally managed together. And then there you can also separate by different branches if you have different admin teams, right? It's very easy to permission different branches and different parts of your repo through Git as well. So then, and then on top of that, the part I think we've not tackled as much, we haven't seen a lot of organic solutions on either is the analytics layer. Nobody has done a great job analyzing and explaining policies or simulating policies. So that I think is the next very challenging problem that we have to solve together. My knowledge might not be complete. Are there existing kind of components in CNCF that are to do with how we analyze and simulate and explain policies? Does anybody know? So that might be an opportunity, for us to think about what we can build to, make management of these policies simpler. I think standardizing error message is a fairly simple thing and probably low-hanging fruit that can get a lot of results already. We'd love to see if there's thoughts on, how we converge. Yes, ideas at the back.
Yeah, I think what if we just, you see, the apps often have some requirements that has to meet. So we add tests to the apps and try to emulate the cloud environment, maybe with a simulator or something, and just let it pass all the tests, like with RBAC, and see if this request is passed and that is not permitted, something like that.
Are you thinking about, is it like a sandbox environment, a staging environment?
Maybe more particular, like a emulator for each kind of service.
Okay.
But sandbox will work fine, I think.
Yeah, so if we have, and then is it possible to build some kind of emulator framework that each of these policies can plug in, right?
Yes.
And then express their simulation results in a similar way, so then we can compile them together. Eventually, all of them
Yes.
have to say yes for you to have access to something, right?
Yes. So if something has passed and the app didn't up, we know where to add tests, and somehow make us live better to say that, oh, this app can go to that network.
Yeah. So that will be very exciting too if we start working on something like that in CNCF. I think there's a lot of desire for that. When we talk to customers who use say IAM on GCP, a lot of time I ask them, what do you like a simulator? They say, why haven't you built one last year already? I'll totally pay for it. It's will be one of the most useful tools. And then another idea on the other side.
Thank you. There's some friction there with the audit logs themselves, which are the source of truth for RBAC denials. There is sort of evidence and issue trackers suggesting that that is not something that the developers want to surface to the end users, which is kind of have mixed feelings about, because it is the source of truth for debugging RBAC, but it's not readily accessible because it's sort of like hidden away. I don't really know what the answer to that is. Maybe sort of like a centralized log with a specific RBAC permission to read just enough. I don't know. And the other thing is, like, on the nature of simulation, the RBAC CANI like interface for kube control is like super powerful, and like obviously the basis for testing those things dynamically. So maybe some sort of kind of cumulative CANI, which then hits all the policy points and tries to bring back something there, could be like going some way towards that simulation. Of course, the difficult part is actually building all the mocked or stubbed environments to test against. But yeah, I fully support that idea. That would be great.
Yeah, you brought up a really good point. It's a trade-off you almost have to make, right? When you provide a lot of data, you can, the more data you have, the more it's possible to analyze and explain and simulate. However, things from, results and errors from your policy checks actually often carry sensitive information, right? They're either PI information, sensitive information to applications, or they can also be things that a hacker can use to try to bypass the system, figure out how to hack into a system. So there is a pool between, the more information, the better for analytics, but it also, to some extent, can weaken your system, your defense as well. And I think that, brought up a very good point. Like, if there are places where we can aggregate those information, right? The raw information is something you don't want an end user or hacker to be able to easily get a hands on. However, the aggregated information, the final recommendation or suggestions, that's where we can kind of hide the sensitive information, right? Make it more about the policy you're looking at rather than the data that might get leaked in the errors. Auto logging is another interesting thing here. We've seen kind of first you have auto logs and people say auto log on and off, and then you start developing more granular auto logging policies as well, right? You want to say, for example, only auto log the user accesses to these resources, and not the service account accesses, because those tend to be noise. Those tend to be just system automation. And then that becomes another place somebody can potentially try to access something but turn off the auto logging and give them away out of the system as well. So yeah, that's a fascinating problem to solve. So when we thought about simulation, how do you explain a policy, a number of models seem possible to explore. I think be able to have an emulator, right, and allow different policies to plug in and give you the end result of the simulation is one option. We've also thought about sandboxing, just easily recreate an environment and then be able to run your policy through. That's another option. Another option that have come up is to rerun your production traffic. So if you can capture production traffic from the last hours, days, right, and then you can identify representative traffic and then run them through the new policies. And then you can tell, without turning the policies on, you can simulate and tell what results you might get. And then we've also, of course, with machine learning, anytime the problem gets complex, we always wonder, what if we throw a little machine learning on it? Is it possible to identify, again, the typical traffic and the typical responses to the new policies? So yeah, I mean, I would love to see, that's something I think everybody I've talked to, all the different companies, all the different Kubernetes users I've talked to, that everybody's fairly early on in analyzing and simulating policies, and that's an area we'd love to see some development in CNCF. If we can come up with some kind of standard framework for doing so, right, and then all the other policies can just plug in, eventually will benefit the user experience and the security of a hybrid cloud overall. So I already saw the 5-minute warning. Probably have the last 2-3 minutes. Anybody else wants to make any closing remark? Okay, then I think we're probably good for today. Thank you. Stay in touch. We'd love to hear if you're starting to make an simulator framework or auto logging framework. We'd love to collaborate together on those things. Thank you.